In the latest update from Neuralink, Elon Musk's brain implant company, we have received information about the first human patient. Neuralink has embarked on a highly controversial medical experiment, bringing science fiction into the real world, potentially without fully considering the consequences of a cyborg revolution. Neuralink has now made its debut, and the question arises, what comes next? But before we go to the good stuff, please use some time to like this video and hit the subscribe button. On January 28, 2024, Neuralink, under Elon Musk's leadership, performed its inaugural robotic operation on a human brain. The patient underwent the implantation of 64 wires directly into their cerebral cortex. Each wire contains 16 microscopic electrode sensors, and a small battery-powered computer device was placed inside the person's skull. After the incision was closed, the N1 chip was activated for the first time in a live human being. Elon Musk has confirmed that the patient, known as Patient Zero, successfully underwent the procedure and is recovering well. Musk also mentioned that the Neuralink device has already shown promising results in detecting neuron spikes, a development that has been 8 years in the making. Until now, Neuralink has been viewed as purely speculative science fiction, but in 2024, it has become a reality that actually works. Elon Musk has achieved the remarkable feat of implanting a Fitbit-like device inside someone's skull. So, what comes next? Elon Musk promises that the first Neuralink product to be tested is called Telepathy. By this, he means the initial software application that will harness the capabilities of the N1 device implanted in at least one human being's skull. Neuralink's telepathy will allow users to control a smartphone or computer simply by using their thoughts. Moreover, the Neuralink patient can use telepathy to control any external device connected to their computer or smartphone. In theory, telepathy should enable users to reach out and control a wide range of devices. It is crucial to acknowledge that Neuralink has not only created superhuman cyborgs. In fact, Patient Zero and the other initial users of Neuralink are individuals suffering from extreme physical disabilities, particularly full-body paralysis. The primary objective of this initial clinical trial is to restore some level of autonomy to individuals who have the least independence. The first demonstrated application of Neuralink is telepathic typing and cursor control. By merely thinking about the cursor's movement on a computer screen, Neuralink allows users to write messages, open applications, browse the web, and even play video games. This functionality has already been demonstrated in the company's monkey experiments over the years, so it is reasonable to assume that the first human Neuralink users are currently utilizing these capabilities. As Elon pointed out, if you can operate a smartphone, you can control any smart device connected to it. Therefore, even without the ability to move or speak, patients could adjust their thermostat, dim the lights, open blinds, activate a Roomba, or lock their doors. All these Internet of Things-enabled devices are now accessible through Neuralink's telepathy. However, Elon Musk has more ambitious plans for Neuralink's first human trials. He has teased another application called Blindsight. Surprisingly optimistic in recent months, Musk believes that even an early version of Neuralink could restore eyesight to blind individuals. The concept involves transmitting digital vision from a camera directly into the brain using the N1 implant. While this application is further down the line, it is theoretically possible. With telepathy, the Neuralink device functions solely as a transmitter. The implanted wires pick up neuroactivation signals from the cerebral cortex, which are then converted into computer language by the N1 chip and broadcast via Bluetooth to a nearby computer or device. If this process is feasible, it stands to reason that the reverse can also be achieved. Digital information from a device could be transmitted via Bluetooth to the N1 implant, which would convert the signal into neuron activations. By implanting the wires directly into the brain's visual cortex region, specific patterns of neuron activation could be interpreted by the brain as visual input. Consequently, even individuals who have never seen with their eyes before could visualize the world around them. This vision would not resemble natural eyesight, but a low-resolution black and white image could be possible by activating the right neurons in the right patterns. It would be akin to an old Atari video game from the 1970s, where each pixel on the screen is either on or off. The graphics were limited, but it was still possible to create recognizable images. Similarly, with advancements in video game technology, it is conceivable that this new digital brain vision could progress and become more detailed over time. Neuralink has always been at the forefront of brain-computer interface technology, capturing the attention of the world. However, it is just one piece of a larger puzzle that neuroscientists have been trying to solve for decades: understanding the human brain. The pursuit of decoding the human brain is expected to become a multi-trillion-dollar industry in the future, and Neuralink will face stiff competition. Nonetheless, Elon Musk's radical pursuit of innovation may give Neuralink the best chance of success. Another BCI startup, Synchron, has already completed its first round of human trials in 2023. They have implanted their own neuron-sensing electrodes into 10 patients using a less invasive procedure compared to Neuralink. Instead of accessing the brain through the skull, Synchron uses a stent-based procedure called stent-ROAD. This involves inserting a wire, known as a stent, into a blood vessel, which acts as a direct pathway to the cerebral cortex. An expandable mesh with 16 electrode sensors is deployed in the brain, allowing for the detection and transmission of neural activity. While Synchron has made progress, it is currently funded by Jeff Bezos and Bill Gates, who have shown animosity towards Elon Musk. In comparison, Neuralink's approach is more invasive. They have implanted 64 wires with 16 electrodes each into the surface of the brain using a surgical robot. This totals 1,024 individual electrodes distributed across the patient's skull. Despite the disadvantage on paper, Synchron's BCI can achieve similar functions to Neuralink's current telepathy system, such as basic control over a keyboard, mouse, and smartphone. Synchron has a head start with 10 active human patients, but their stent-ROAD system has limitations, primarily controlling a smartphone telepathically. Neuralink, on the other hand, has a long-term outlook that is almost incomprehensible. While their current telepathy application utilizes only a fraction of the hardware's potential, Elon Musk speculates about various outcomes, including curing brain diseases, correcting mental illness, combating obesity, and connecting the human brain with artificial superintelligence. While there is no concrete evidence to support these claims, there is also no evidence to disprove them. The full potential of Neuralink remains unknown, but another BCI technology, BlackRock Neurotech, has come close. They have been involved in invasive BCIs for almost 20 years, using electrode pins to access the brain's surface. Despite their relatively primitive approach, BlackRock has achieved telepathic control over a computer and enabled individuals to control robotic arms and regain mobility. Neuralink, with its more advanced technology, has the potential to surpass BlackRock in a shorter time frame. The captivating aspect of Neuralink lies in its long-term perspective. Its high-bandwidth connection between the brain and computer sets it apart from any other device on the market. With thousands of electrodes going deeper into the brain, Neuralink has the potential to redefine what is possible with the human brain. Exciting discoveries are expected to be revealed this year, solidifying Neuralink's position as a groundbreaking technology in the field of brain-computer interfaces. Thank you for watching. Before you go, please leave your thoughts in the comment section, subscribe, and stay tuned for more updates.